Now let's move on to example number 6. A baseball is hit 4 feet above the ground and leaves the bat at a speed of 105 feet per second at an angle of 40 degrees to the ground. Write a vector that describes the motion of the ball. Alright, so in order to write the vector, we need to use this theorem, position vector for a projectile. Neglecting air resistance, the path of the projectile lunges from an initial height with the initial speed v0 and an angle of elevation theta is described by the vector function r of t equals v0 cosine theta t I plus h plus v0 sine theta t minus 1 over 2 g t squared j, where g is the acceleration due to gravity. G equals 32 feet per second square or 9.8 meter per second square. To derive this formula, I'm going to prove this formula in the separate video. Alright, we just apply this one into this problem. Now we're going to summarize this one 4 feet above the ground, which is h equals 4, right? The speed 105 feet per second. This one is the initial speed. So v0 equals 105, right? The angle, which is theta, equals 40, right? Now we have r of t equals v0 cosine theta, right? So it's going to be 105 cosine 40 degree, right? Times t plus h equals 4 plus v0, which means 105 sine theta, which is 40 degree, times t minus 1 over 2 g equals 32, right? Because the unit right here is feet, right? So you're going to use 32. 32 divided by 2, it could be 16, right? So I have 16 over here, t squared. And this one is the j component. And remember, this guy actually the s component, right? And this guy right here actually y component, right? Now question B, determine how high the ball goes, which means the question asks you to find the maximum height. So we look at the y component right here, right? So we need to maximize this function, right? So in order to do that, we're gonna take the first derivative, right? So we have y prime of t equals 105 sine 40 minus 32t, right? Then you're gonna let y prime t equals 0, so that you're gonna find the critical number, right? So it's gonna be negative 32t equals negative 105 sine 40 degree, right? And then t equals 105 sine 40 degree divided by 32. Now you're gonna bring up the calculator. Alright, you're gonna press calculate. And then you look at the upper right corner right here. This guy must be degree because you have degree right here, right? So if it's radian, you need to convert it to degree, right? So you're gonna press the fraction right here, put this guy, and then it's gonna be 105 trig sine of 40, right? Over 32, and then you're gonna press enter, right? you need to convert this one to decimal. So you're gonna press Control equals right here. It's gonna give you 2.109. Right? Don't forget to include the units, right? So it could be seconds. Question C. There is a 12 feet high fence 325 feet from home plate. Is the ball a home run? Alright, so we have S of t equals 325, right? But S of t is right here, right? 105 cosine 40 degree t, right? So I'm going to let this one equals 105 cosine of 40 degree t. So I'm going to solve for t, right? So t equals 325 divided by 104 cosine of 40, right? Now I'm going to bring up the calculator, right? So I'm going to press this guy and put a fraction. It's going to be 325 over 104 times cosine of 40 degree, right? And press enter. Convert this one to decimal. So it's going to be Control enter right here. It's going to be 4.07, right? Now we're going to use this value to calculate the height, right? So we have y of 4.079. We're going to use this function right here. Alright, so it's going to be, now I'm bringing up the calculator, right? So I'm going to press 4 plus 105 times sine of 40. And then times 4.079 minus 16 times 4.079 altogether square, right? Press enter. It's gonna be 13.0909. This guy right here is greater than this guy right here, right? 12 feet. So you're gonna say yes, the ball is a home run. Now let's move on to example number 7. Water from a fire hose is discharged at a maximum rate of 80 feet per second from a height 4 feet from the ground. Firefighters can get 25 feet from a burning building. They shoot the water from their hose at an angle of 45 degrees to the ground. Question A. What is the maximum height that the water can reach? Remember, we have the position function. It's going to be R of t is S of t I plus Y of t j, right? And we're going to use the theorem right here, right? So we're going to summarize this one. 80 feet per second. This one is the rate, right? So it's going to be initial velocity, right? And the height right here, this one is the initial height, right? And 45 degrees right here, this one is the angle theta, right? So we have S of t equals V0 cosine theta. So it's going to be 80 times cosine of 45 degree, right? Times ti. For plus 80 sine 45 degree, right? Times t minus 1/2 gt squared, right? Which is 16t squared, right? This one is the J component. Now, we're gonna use the Y component only. To find the maximum height, we need to take derivative of this one. And then we're gonna find the critical number, right? So it could be negative 32t plus 80 sine 45 degree, right? And then we're gonna let this one equals 0. We solve for t, right? So t equals 80 sine 45 degree divided by 32, right? And then I'm gonna bring up the calculator. Then it's gonna be 80 times sine of 45 degree over 32, right? Make sure your calculator should be in the degree mode, right? So you're gonna press enter. Then you're gonna convert this one to decimal. So press Control Enter. It's gonna be 1.76777, right? You're gonna find y of 1.76777, right? Negative 16 times 1.7677 square plus 80 times 1.7677 times sine 45 degree plus 4, right? So this one should be 54 feet. Now question B. If the building completely burns down and the firemen are shooting water on the wreckage, how far into the wreckage can the water reach? So the question just asks you S of T. Now if you get the pictures, the fireman is right here and the fireman is shooting water. Then when water hits the ground, the vertical component equals 0, right? Which is this guy right here equals 0, right? So you have y of t equals 0. You need to solve for t, right? So I'm gonna bring up the calculator. I just store the function y of t, right? So I'm gonna press y of t. And then I'm gonna press Control and this button right here next to number 9. And then I'm gonna put the function negative 16t squared plus 80t times sine of 45 degree plus 4. And then I'm gonna press enter. So I'm gonna go to the home screen graph and then I just put y of s. That's it, because I already stored the function, right? So I'm gonna press enter. It's gonna be right here, right? Now if you zoom this one in, you will see that the values on the left of the y-axis is negative, which does not make sense, right? Because t values cannot be negative number, right? So we're gonna focus on the t value right here, right? So you're gonna press menu, analyze graph, find the 0, right? Move your cursor to the left, move your cursor to the right. The answer is 3.6 right here, right? Now you need to solve for s of 3.6. The function s of t is right here, right? So you have 80 cosine 45 times 3.6, right? So 80 times 3.6 times cosine of 45 degree, right? So I have, now I'm gonna go to the home screen, press calculate. I have 80 times 3.6 times cosine of 45. Press enter. The answer is 203.647. Now we need to answer the question right here. How far into the wreckage can the water reach? Now look at the given information right here. Firefighters can get 25 feet from the burning building, right? So you need to take this one, subtract 25, right? So the answer is 178.647 feet. This one is the final answer, right? Now let's move on to example number 8. A projectile is fired from the ground level at an angle of 10 degrees horizontal. Find the minimum velocity necessary if the projectile is to have a range of 100 feet. R of t equals v0 cosine theta times ti, right? Plus initial height plus v0 sine theta t minus 1/2 gt square, and this one is the j component, right? Now we just plug in values, right? So we have v0 t right here. T is not given, right? Cosine theta, which is cosine 10 degrees, right? And this one is the I component. Plus initial height is 0, right? Look, from the ground level, right? So it's gonna be v0 sine 10 degree, right? T minus g equals 32 divided by 2, it's gonna be 16, so it's gonna be 16 t squared. This one is the j component, right? Now we're gonna sketch the figures. The projectile will start from here, right? And then it's gonna go like this. Then the height right here is 0. The distance from here to here, s of t equals 100 feet, which is given right here, right? And then y right here, when this one hit the ground, y of t equals 0, right? So we have a system of two equations. Now this one right here actually s of t, right? So we have v0 t cosine 10 degree equals 100, right? And this one actually y of t, right? So it could be v0 t sine 10 degree minus 16 t squared equals 0, right? Now to solve this system of equation, I need to solve for v0 from the first equation, right? So first equation v0 equals 100 divided by t cosine 10 degree, right? Second equation, I need to solve for v0. It's gonna be 16 t squared over t sine 10 degree, right? So I just equate these two guys right here, right? Because they both equal v0, right? Now this guy right here, t squared divided by t, I only have t on the top. This guy gone, right? Now I just cross multiply, right? So I have 16 t squared cosine 10 degree equals 100 sine 10 degree, right? So t squared equals 100 sine 10 degree divided by 16 cosine 10 degree, right? So this guy turns out to be, divide the top bottom by 4, right? So it's gonna be 25 over 4, right? Sine 10 divided by cosine 10 is gonna be tangent 10, right? Now I'm gonna take square root both sides, so t equals square root of 25 over 4, which is 5 over 2, right? Tangent 10 right here, right? Actually, you have two values. It's going to be positive and negative. But because the time t always positive, right? So I eliminate the negative number, right? So I'm going to bring up the calculator. So it's going to be 5 over 2, which is 2.5 times square root of tangent 10 degrees, right? Then I'm gonna press enter. It's gonna be 1.04978. Now I'm gonna substitute 1.04978 into one of these equations. Then we're gonna finish, right? So I'm gonna bring up the calculator. Now I'm gonna use the first equation, right? It's gonna be 100 divided by this value right here. I copy this one down over here. Don't forget parentheses. Times cosine 10 degree. Then you're gonna press enter. The answer is 96.7273. Feet per second. And it's your time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand